Welcome to Presentation 25. Today's subject will be the display 128 by 64 pixels in resolution, and it's going to be an I2C type display. As usual, I start by showing you our architecture. The display belongs to the layer 3 architecture, and in support of the display we use the I2C framework, which is part of our layer 2 architecture. Now the agenda for today. So I'm going to give you a description of the display. Next, we looked at the data sheet, followed by a description of the functionality. Then we'll go to a sample program, and we'll finish with the a summary. So let's get going. So this shows you the display, and I put a 25-cent coin next to it so you can kind of get an idea of the size. It's a fairly small display. This is from the back of the display. It has 4 pins, one for power, ground, and then it has 2 for the I2C, the SDL, and the SDA. Now that's the part number. And we looked at the part number and found out that the controller associated with this display is the SSD1306. That's important information because that's how we go about finding the data sheet associated with this display. So let's look at some of the detail. So the size is 0.96 inches. The resolution, as I noted, is 128 pixels by 64. 128 pixels. Next, the voltage, we're going to use a 5 volts, but it should also work with a 3.3 volts. Next, as I noted, the embedded driver is going to be the SSD1306. Communication, I2C. Black light, there is no need for black light, which is great because that helps us with 2 less wires. And finally, there are no fonts embedded in the OLED controller. User has to create its own fonts or characters. So basically, we're going to use the framework we developed in Presentation 24 that shows you how to create characters. Next, this gives you an idea of how the controller is going to be hooked up to the display. So we are going to have a couple of lines, one SDL and then one is SDL, LDA, one the controllers and the display are going to be hooked up to those lines, and those lines are going to be hooked up to the voltage by 4.7 kilo ohms. So let's start by looking at the data sheet. This data sheet contains all the information for our controller. The number is SSD1306. My goal here is to give you highlights of this document so you are somewhat familiar, or at least know where to get started. So let's look at the features. This section in particular is going to give you some information about the display, such as the resolutions, the voltage, and so forth and so on. Another section that is worthwhile looking at in this highlights series, I should say, is the one that talks about the I2C. It gives you a lot of information on how to communicate on the I2C bus. For example, here we have the formats of the word. One thing that that is interesting, for example, if you want to send a command, then you would set the data command bit to 0. And then if you send data, then you would set up that bit to 1. Now that's something that's going to be, I'm going to explain it in my presentation, but I just wanted to give you an idea where I got some of information. So let's go to section 9, and the nice thing about section 9 is that it has a description, it has the table with all the commands, I should say. So here you have all the commands that you can send to the display, and of course when you send the command, then you send the data associated with that command. So this is the command and how to set the bits and what's going to be the outcome when you set each of the bits. And also we have section 10. In section 10, what they do is they actually go through a explanation of what each of the commands do. So how to set the lower column, set the higher column, the start. So basically before you start displaying something, you have to set the page and the column, and here they tell you how to do it, and pretty useful information. How the displays are going, how the pixels are going to be displayed from left to right or up to down. Now another good piece of information, very useful I should say, has to do on how to initialize our display. Initializing display is something that most of the time is difficult, and the reason it's difficult is because you don't know that much about your display. You haven't learned that much, but still you would like to be able to display something and then learn as you do. So in this section here, in section 3, software configuration, they have an example of how to initialize your display, and basically gives you a good idea of the items that you have to consider as you go initializing your display. Because sometimes to be able to initialize your display, you have to actually have a lot of knowledge of your display, and sometimes we don't. So you can just use one of these examples to get you going, and then as you learn more on your display by using and experimenting, then you can change the initializations or change different parameters. So with that, I giving you a highlight of the document, and let's continue with my presentation so we can learn about the commands and how to program the display. Okay, so there you got the idea about the data sheet, and now what I have here is a list of all the commands. The ones we're going to use the most are going to be how to set the columns and how to set the page. Now these other commands are also very useful, and as you experiment with your display, you'll be able to get familiar with them. Now the ones that are kind of nice, I've used these scroll commands, and they're pretty nice in the sense that you can put something on your display, and then you activate or deactivate the scroll, and you have different options of how you want it to be scrolled. So now let's talk about the command and data. So if we want to send a command to the display, so let me back up. So the way the display works is we send command and then we send the data. The command tells the displays what to do with the data. So let's look at the command transaction. So we send the start. Now the start, that's an I2C protocol. So we send the start, address parts right. Then we send a 0, which tells the display that we're going to send a command. And then the command follows, and then we stop. So I square C, we send the 0, the command, and then the I square C again. So this 0 is going to have 8 bits, and the data command bit is going to be 0, which is this bit here. Now let's look how we send data. So first we send the start command as usual, required by I square C. We send the address plus write. Then we send the hex 40. That states that what follows is data. Then we send the data and then we stop. The hex 40 is basically the second bit is 1, which tells the display, hey, what follows is data. So let's look at the code. So now all this code is cut and paste mostly from our I2C presentation. So here we go, display command. So it means I want to send a command to the display. So we send the TWI start, then we do TW transmit plus write and the address of the display, followed by zeros. Then we send the command and then the stop. Now let's see how we go about sending data. So again, we send the start, we send the transmit address plus write. Now those are the two statements required by I2C. Then the data follow, which is write 40, which is what follows is data, and then we send the data and then we stop. So this is just sending a 0 or sending a command or sending data following just the I2C protocol. Now let's look at some specifics about the display. Display is 128 pixels by 64. Now how they've organized this? They've organized the display, they've broken down into 8 pages. And each page has 128 columns. Let's see what this, let's look at one page. So let's look at page 2. So if you go to page 2, you're going to have you're going to have 128 bits, 128 columns of 8 bits each. So when we send a word to the display, we have to do two things. We have to tell it in which place it's going to place it, and then once you know the page, in what column of that page is going to place it. So let's look at the code. So we have to set the cursor, so it's display set cursor. So we're going to send the page and the column. So the first thing we send the command, which is Bravo 0 B0 plus the page. This page again can be between 0 and 7. And once you send that, then the display know exactly in which page you want to set the display, in what page you want to have the display. Next thing we need to do is we have to tell it, once we got to the page, we need to tell him which column. So to do the column, you have to send two commands. Now the value of the column is between 0 and 127. So you take the first, you send a 0, and then you send it your first, the lower value, the lower value of your word, the 4 bits. So you take and you add your column to your 0F, which basically eliminates the higher bits and sends the lower. Next, you send a hex 10 plus. You're going to send now the higher columns. So to send the higher column, you shift everything 4 places to the right, and then you end it again with the 0F. So you just send again the 4 bits. So that's how you do it. So you break your word into 2 pieces. You send the higher portion and the lower portion. So that gives you your page and your column. You know where to get this way and how to go this way. Now, This is what I showed you we developed in presentation 24, last presentation, how to create characters. So now if I want to send the A to the display, so what I do is I tell it what page and what column to start. Let's assume we start right here on page 2 in column 0. So then I'm going to send it a 7F. What it's going to do, every time it sees a 1, it's going to turn on the pixel. If it's a 0, it's going to turn off the pixel. So I'm going to send it a 7E. So the 7E is going to place it right here. Now this goes from the least significant to the most significant, same as the word that I developed, from the least significant to the most significant. So I'm going to send, if I want to put the A, I'm going to send it 7E, 11, 11, 11, and 7E, all hex number, of course. And it's going to play them here, and you'll see in the display show up this A. So let me just backtrack one time. We select the pages, we select the columns, and we send the data. Use the commands to select where we want these things to start. Okay, let's go through our example program. So first we want the screen to be cleared. Then starting on column 1, on each page, display the following. Now each page is equivalent to each row, basically. So I wanted to go through the 8 pages and display this statement, row 1, column 1, row 2, so forth. So I wanted to display this so you can see how each of the pages. Next, I wanted to wait 300 milliseconds and then clear the screen and finally display all the ASCII characters. Those are the ASCII characters that we developed during our presentation, past presentation. Excuse me. So here we have how we're going to connect things. We have the 328 SDL and SEL hooked up to the SDL and SEL line. The same goes for the display, and each of the lines are hooked up to a voltage with a 4.7 kilo ohms in between. So let's look at the code, how we do this. I will first give you a high level of all these routines, and then we'll get into details. So this one here, the TWI init, that's the routine that initializes the I2C. TWI start, that's the I2C start. We have the I2C stop and the I2C write. Now these 4 routines I just cut and paste from the code that we had developed during the presentation on I2C, so there's nothing new here. Next, I have here the TWI transmit address plus write. Again, that's the I2 protocol transmit plus write. This is another routine which I just cut and paste from the code we developed for the I2C presentations. There's nothing new there. Now next we have the display init. That's something new that relates to the display itself. Then we have here the display send a command. I should say transmit command. We have transmit data. Then we have a routine which sets the cursor. That's where we're going to start our write in the display. Next, we have a routine to display fill, which is going to fill up the display with certain pattern that we select. Now, this is just a routine that clears the display. Here we have a write chart, which is going to write to the display our ASCII character. And then we have the write string. So a write string basically parses characters and they get displayed by write character. Next, we have our main routine where we're going to request that things get displayed, and also we're going to display all our characters as requested by the statement, by the sample program statement. So let's get into the details. So as I noted before, all the I2C stuff that we've already done, we're not going to repeat them here. So we have the TWI init, start, stop, write, and the transmit plus write. I'm not going to talk about those things because they were explained in the I2C, and you can go back and review that. So let's start by the display init. Now, as I noted when I was going through the data sheet, the display init is difficult because in the sense that you don't know when you get started, you don't know enough about your display, and as you go, you learn and you would change this init. But what you have here is some basic stuff that's going to get you start, and with reasonable results. So let's look at some of the parameters. You have the display of, horizontal addressing mode, how the things are going to flow, start page, which is we're going to do B0, we're going to use that. Low column address, high column address, that's what the commands are going to look like. The start line, we have contrast, for example, display offset, display clock, com pins, enable charge PAM, and then we end up with display on. So anyhow, I think it's enough to say that this init is something that you have to get something that works for your particular display. And if you're using the display I'm using, then you can just go ahead and use this init routine and then just change it so it meets your requirements. Now, this we have this routine display command. So what we do here is first, what we want to do is we want to send a command from the microcontroller to the display. So I2C protocol, we send the start, then we send this the transmit address plus write. Next, we send, as I noted, the command which is 0, and then you follow by the command. And once you've done that, you stop. The command is an input to one of the routines. Now the display address, let's go back and look at the display address. So the display address is defined right here. Display address as 3 hex, and we got that from the data sheet, the specification. Okay, so now let's look at transmit data. Transmit data is very similar to the transmit command, except that we're going to send a 1 instead of the 0 for the data command portion of the word. So we do the start, that's I2C protocol, transmit plus write, again I2C protocol, then we send, hey, the command is 4 hex, which means that data follow, then we send the data and we stop. Now next comes the display set cursor. Now when you're going to start writing, the initial location where you're going to start writing, you need to select the page and you need to select the column. So the command to select the page is hex B0 plus the page where you want to start. You'll go from page 0 to page 7. Next, you have the column where you want to start. The column, you're going to have to send 2 messages to define the column, and the lower portion, that would be the 4 lower bits, and then the higher level 4 higher level bits. Why do we do this? Is because that's what the data sheet says. That's how we're supposed to do it. So we send the command 00, which is the lower column follows plus the column, and then to make sure everything works out okay, what we do is we mask the higher 4 bits. So we have 4 zeros and 4 ones. So we add it to the columns, and that gives us the lower 4. Next, we have to send the hex 10 plus the higher value. So what we do is we shift everything 4 places to the right, and then we add it to make sure that we only send the stuff that we've shifted 4 places, and that gives us the 0F. X as 0F. So basically we send the page plus we send the first lower bits of the column we want, and then we send the higher bits of the column we want. That's how we set the cursor, and that's where the write is going to get started. Now display field. Sometimes you want to just blank the display, so you need to have a means for filling the whole thing. So what do we do? So we have first a 4 from 0 to 7. So that's going to be, we have 8 pages, page 0 through 7. So we go to the first page, and so this says, hey, I want the first page and I want to start at column 0. And then I start my I2C routine to send that particular page. So we go TW start, transmit plus write. I send a 4, which means what follows data, and then I send from 0 to 128, which is the number of columns that I have, 127 columns actually, and I write the pattern. Then once I'm done with that, then I stop, and then I go and get the next page. Now the reason I went ahead and did the TW start and transmit plus write and do all the TW stop, basically do all the I2 at this level, because it makes it much faster and have to call some other routine like display data. So that's why I did this here. And so that way you go through your 8 pages and you write your columns for each of the pages. That's for the display field. Now we have the display clear, which is basically what it does is just calls the display fields and fills it up with a with 0. Display field, it fills it of any pattern you want. The clear, what it does is wipes out everything. All you have is a blank display. So that's a little different. Now here I have the write chart that's going to write our ASCII character. So what we do is we transmit an ASCII character. Next, that ASCII character is sent to the display data, which is basically transmits this data to the through the I2C so it can be displayed. So that's going to be, we have the ASCII character, which is the first number in the array, and then the other one is 1 through 5, which is all the words that will form that particular character. Next, we add a space, and then that's going to create, that's going to display the first character. So we have the first character plus a space. Now we have write string. So what we have, you get a string to this routine, and what you do is you parse the string character by character, and then you send it to write character, which is this one, and it writes the character into the display. Okay, finally we got to the main program. So let's see what we're going to do here. So we initialize the I2C TWI init. That comes all from the I2C presentation. Next, we initialize the display, which we got the information from the data sheet, and you were able to get a flavor of what it is. Then we clear the display, because what we want to do is start with a blank display. We wait 1 second, and then we have the following. What we really want to do, we want to display row 1, column 1, row 2, column 1, row 3, column 1, row 4, 5, 6, 7, and 8, and column 1. That's what we want to display. So the first thing we want to do is we said, okay, where do we want it to be displayed? So we set the cursor position page 0, position 1. Then we go page 1, page 2, page 3, page 4, page 5, page 6, page 7, and and all in position 1. Then once we display all these messages, that's going to give us an idea. What I wanted to do is show the 8 columns that we have at our position and what that would look like. And then we're going to delay for 300 milliseconds. You can see so you can actually see what was displayed or printed on the display. Then we clear the display again, make everything clean. And then what I'm going to do here is I'm going to print ASCII characters between 32 and 127. Those are all the symbols that we have in the ASCII characters. You can see what they look on the display. So what I do is I start with 32, and then it displays the right chart is going to actually put that character on the display, and then I add 3 blank spaces, and then I go and get the next one. So let's go back and look at the display right character. So here we have the right character. So it gets the ASCII number, which is the character, and then displays all the words that are going to take to compose that character in the screen. Okay, then we go to the forever loop. So let's look at the details. So this is the actual outcome of the program, and you can see as you can see what it displayed. So let me do it again. Oops, let me go back here. I'm sorry. So let me see. Let me do it one more time. You can see here the displays, and here you have all the ASCII characters. So with that, let's go back to our presentation, and let's continue with our presentation. But I think this gave you a good idea of what the source code, and also an idea of what would get displayed. Okay, so this example showed you what the characters are going to look like that we developed in our presentation on how to put together characters, and we use the actual framework, ASCII framework. So with that, we've gotten to the end of the presentation, and let's go through a summary. So today I gave you an idea, a description of the display. We looked at the data sheet. I talked about the functionality of the display. We went through a sample program. And here we are at the summary. So I hope you've enjoyed this presentation, and hope to see you again in the next one. Thank you very much.